Greetings and welcome to episode 28 of the Sustaining the Herd podcast, brought to you by Agri-Services and Engineering of Raymond, Nebraska. I'm Andrew Wadle, and I'm joined in the studio with my co-host Brock Vitek.
Hey there, Andrew.
And we are joined in the studio with our special guest today, Jacob Hansen of ALA Engineering.
Yeah, good to be here.
And we're going to give Jacob an opportunity to introduce himself and ALA Engineering here in a moment, but just wanted to say welcome back to all of our past listeners, and we're super glad that you've come back and you're finding value in everything that we talk about. And just a little bit for our new listeners, and Sustaining the Herd is really dedicated to everything involving animal agriculture, sustainability related to animal agriculture, and agriculture in general. And really we see sustainability fitting into three different categories, and there's probably a lot more, but just quite simply, first would be protecting the air and the water. That is the air we breathe and the water that we drink. Everybody wants clean air and water. It means, taking good care of the animals that we rely on for food and fiber, etc. The second would be efficiency. Sustainability is related to efficiency, and that is doing more with less, maximizing our resources. And the third part of sustainability is sustainable businesses. We need to have businesses that are sustainable so that they continue to exist in the process of agriculture and feeding us and clothing us, etc. And that means, in addition to farming operations, it means all the businesses surrounding farming, and that kind of leads us to our special guest today, Jacob Hansen of ALA Engineering.
Jacob, thanks for being here today. Little context for our listeners. Jacob, I think it was, probably almost 2 years ago now, or right around there, when we first met at the Nebraska Ag Tech Connect conference hosted by the Combine Incubator on Innovation Campus here in Lincoln. And it's been fun to stay caught up with you since then, to see and hear about all the great things you and your team at ALA Engineering are doing. And I'm glad that we could kind of have things come full circle and have you here on Sustaining the Herd. So with that, would you please introduce yourself and your company?
Yeah, so my name is Jacob Hansen, and I feed cattle. It happens to be a little bit non-traditional in the sense that we're doing it with 60,000-pound robots. But we've been at this officially as a company since 2019. But my two co-founders actually kind of started this process of feedlot innovation back in 2008 through a prototype for an electric feed truck, and through the 2010s with kind of prototyping GPS auto steer for feed trucks. And now we're into full autonomy. And so we've been able to build a really great team focused 100% on bringing autonomy to the feedlot, and we're really close to hitting production and actually getting the product out into producers' hands.
Jacob, just we always have segments of our episodes where we call it kind of like the people in town segment, because there's a lot of people in town that listen to us and they don't quite know what folks mean by feeding cattle. Can you let's just say a moderate size feedlot or a large feedlot, what does it mean to feed cattle? What does that operation look like?
Yeah, so for us, we operate in cattle feed yards, feedlots, and so we're talking about commercial scale cattle feeding and finishing operations. Specifically, we're talking about truck fed operations where there are trucks on site that may have mixer boxes or delivery boxes mounted on the back. They get filled up with whatever ration a certain pen needs, and they drive out through the yard and deliver that into a long, usually concrete bunk that the cattle actually eat at. And so what we're doing is we're taking the ration and the feed that's needed for the herd from the mill to the bunk, and distributing that feed across the entire length of the bunk consistently so that the animals can eat.
Very interesting. And Jacob, you started to get into some of the history of the company and some of your own personal history in your introduction, but I'd like to take that a step deeper if we could and just ask about, what is your background that brought you, prepared you for the role that you're in today, and what's a little more of the expanded version of the history of ALA, growing out of ALEC, et cetera.
Yeah, so I'm from Western Nebraska. Didn't grow up directly in an ag family, but grew up on a hobby farm and grew up, very around ag. Went to UNL for software engineering, and really thought I was going to end up either on one of the coasts or down in Texas in some sort of robotaxi or on highway autonomous trucking company. And it turns out there's a massive need for that in agriculture right here in Nebraska. So I was able to kind of merge the autonomy and the trucking side of things into agriculture, with my two co-founders of ALA Engineering. And so, kind of like I mentioned, my two co-founders, Vince and Austin Aulick, run Aulick Industries. And so they're kind of a medium-sized agricultural equipment manufacturer in Scottsbluff, Nebraska, with locations all across the country. Their bread and butter is live bottom belt and chain floor trailers and infield dump carts and the like. But they also have a couple of decades of experience working with feedlots for truck upfits, maintenance, rebuilds, mounting feed mixers, all sorts of things. And so there's this long history of working with feedlots to build the best truck that we can, and to make sure that truck can go and live a long life in one of the worst environments for a truck. So in 2019, we spun off ALA Engineering as its own company to allow us to focus and innovate a little bit faster in the autonomous truck space. And we've been through multiple technological iterations since then. So the first kind of iteration was more of our proof of concept, and it was a driver information system that just took all of the variables that a feed truck driver has to keep track of in order to feed safely and reliably and consistently, and brought it all onto a single screen. So all they had to do was kind of match speed with their feed output by lining these two progress bars up. And it took a lot of the guesswork out and really got us down to single pass feeding consistently, which is really hard to do.
So Jacob, let me just interrupt you there for a second. And again, that's kind of some of the really, really interesting things here. Can you talk about just what that desired state is? About making one pass and making one consistent pass, and what a driver otherwise would have to be looking at to make that all happen.
Yeah, so a feed truck driver, it is one of the harder jobs out there. It's also one of the most expensive pieces of equipment out on a yard, and you're driving around oftentimes too high of speeds and taking corners too fast and all of that. But during an actual feeding run, you have to keep the truck straight and at a perfect distance away from a concrete bunk. And you're driving really close to it. One wrong move, and you're leaving rubber on the side of the bunk, or worse. You have to maintain a really consistent and slow speed, which is difficult to do with a standard truck. And so a lot of times, you'll see drivers, actually riding the brakes and the throttle at the same time to keep your RPMs up for your feed mixer, to keep your PTO RPMs up, but to keep the ground speed low enough that you're actually getting enough feed out into the bunk.
Right.
And with all this, you're trying to be accurate and consistent. And so an unskilled driver or a driver feeding, even if it's an experienced driver just on a new ration that they're not used to, or a new truck and a new box that they're not used to, it's really hard to get the proper amount of feed out, driving past the bunk once. And so what happens oftentimes is they'll get to the end of the bunk and still have 3,500 pounds of feed left to distribute. They'll throw it in reverse and put out that last couple thousand pounds. And now the end of that bunk is overfed and the start of that bunk is underfed.
Right.
And if you do that every day consistently, what we've seen is cattle are like us. I've never met a person who sits at a different spot at the dinner table every night. I think that would be a little crazy. And cattle are the same way. And so if you're consistently going to the same spot at the bunk and the beginning is always underfed, you're going to be getting less feed. And if you're consistently going to the end of the bunk where there's more feed, you're getting overfed. That has longer term implications down the value chain, where you get into the meat processing side of things. And now, your animals are inconsistent size. So now you're getting less per pound. But it also has big implications just on animal health. You don't want to overfeed, you don't want to underfeed, especially if you're talking expensive feeds, medicated feeds. There's all these reasons that you want consistent feed distribution along that bunk, and it's just really hard to do.
Yeah.
And so even just getting some more information in front of the driver, doing some basic calculations of how fast am I going, how far have I traveled, and how many pounds have I output already, we were able to get that information in front of the driver and really get that one pass feeding down. Beyond the animal health side of things, it's easier on the truck too. You're already probably overloaded beyond factory spec on that truck, and now you're getting to the end of the bunk, slamming on the brakes, slamming it in reverse, and going backwards, and that's just hard on equipment. It's not time efficient, it's not fuel efficient, and so it has so many detriments kind of everywhere in the operation: time, fuel efficiency, animal health. And just getting to single pass feeding, you just continue on your way without all of those additional issues.
Yeah, that's really fantastic, and I think that might be you might segue into or may have already even answered my next question, and that is, so between you and your partners, you're very well grounded as far as what goes on in a farming operation, feedlot, cropping operation, et cetera, because you don't just service feedlots, but in any case, of all the operations, what made you decide to automate cattle feeding, as opposed to anything else? There's so much other things in agriculture that could benefit by this technology.
Yes, and we fully believe that over the next 10 years, there will be a lot more applications for this technology. But we came upon the feedlot because it is the intersection of all these different factors. My co-founders have been trying to work with the vocational truck industry for decades, asking for feedlot-specific factory options. Bigger radiators, reversible fans, all of these extra features that we have to install on feed trucks before they go out to the feedlot, that we wish we could just get from the factory. It'd be easier for us, cheaper for the customer. And it's too small of a market for the large vocational truck manufacturers to really give from the factory feedlot specific options. And so that's kind of number one there. Number two is a feedlot is a very well-defined, repetitive, and private operation. And so in field autonomy, you are always in different fields performing different tasks. You never run the same field doing the same thing twice, day after day. In a feedlot, you might have different pens to feed each day, or different rations to feed, but you're running the same routes day in, day out, and all day. So there's no need to transport these trucks between fields across the county trying to get to your different properties. That truck stays on a single property, just going between the mill and the feed bunks. That also ties into, because we're off highway and on private property, there's a lot less safety hazards. There's a lot less, requirements when it comes to things like latency and all of the things that come in when you're going 65 down the highway versus us going 10 miles an hour, in a feedlot. And then the last big thing is cost. Autonomy is expensive. The sensors are expensive. The compute is expensive. The talent and engineering capacity is extremely expensive. And so compared to, say, a robotaxi or a consumer-owned autonomous vehicle, where you have to fight a lot more on cost, and so you have to hit these massive economies of scale to get your LiDAR sensors for less than $5,000 a piece, just so that it's affordable in the feedlot industry, because it's so repetitive, 365 days a year, and hopefully you can have extremely long duty cycles within each day. You can keep that expensive tech busy and producing for you, shortening that ROI compared to lower margin opportunities, or in areas where that autonomous tech might operate less frequently.
That all makes sense, Jacob. And I'd like to ask, you're doing a lot of cool things, and it sounds like you have your market pretty well figured out, but I'd imagine there have probably been some bumps in the road or some challenges along the way too. to get to this point, and I'm sure those still come up from time to time. So what challenges have you encountered so far that you'd be willing to talk about?
Yeah, so I mean, the biggest challenge is we're trying to build a product that doesn't exist in a cutting edge tech space that most companies in the space have $500 million or more in funding, and we obviously do not. And so we're competing in a space where the talent, I guess, first off, is flocking to on highway and urban autonomy because that's where the big VC funding is. That's where the most flashy tech is, the most marketing, and all of that. And in ag, we've had to take it a lot slower and a lot more careful. And so, there's a graveyard out there of autonomy companies that lasted less than 6-7 years, and here we are at the 6-year mark, almost to market, not quite, because we've taken steps very, very carefully. When we first started, I spent the first 3 months in the feed yard every day, driving a standard feed truck, just to get to know the operation as the engineer on the project, to really know the basic building blocks of what cattle feeding takes, what it is, and to learn kind of the issues that come with it. And we think that kind of set us apart early on, in that we figured out the really low level problems before we tried to jump straight into autonomy. And so through that, we figured out through that driver information system stage, we figured out, what is all the equipment, all the communication standards, what's the software that these lots use, how do operators communicate with each other, what are the performance issues, the safety issues, all of these things. We then move into the advanced driver's assistance stage, where we developed an adaptive cruise control for cattle feeding, essentially. And we learned more of those building blocks, like, okay, now that we can feed consistently, how do we start to rein in accuracy? And how do we get to that 10 to 15 pound mark of within, your desired actual feed distribution? And how do you start to communicate with other drivers on the yard that this truck is operating either fully autonomously or partially autonomously? And how do you start to figure out safety frameworks, and stepping into safety certifications and actual marketability of a product? Because it's a whole different ballgame to build a R&D project versus to take that to market in a way that's safe and reliable and legal. And so it's been a really long road, but we've actually had, in terms of expense or risk, very, very, very minimal mistakes because we've taken each step so cautiously. We've been able to do that in a big part because there's not other direct competitors in the space. So we weren't rushing against someone that we knew would be to market in 2 years. We've been able to take it slow and make these decisions more effectively and kind of minimize the big potential risks. But it doesn't mean things don't happen. We've spent time integrating the wrong components into our system. We've made assumptions that certain sensors or certain software algorithms will work great in a feedlot, just to spend a month engineering that and find out it doesn't work. But those are very, very small issues compared to, potential safety issues. We so far have a perfect safety record, and that has been, just incredible. That would have been a really big issue early on in the project, especially in autonomy. One safety incident can kind of sink a company.
It makes the paper.
So,
it makes the news, doesn't it?
It does. It does. And so we've been able to avoid that. We've been able to avoid massive rework and massive engineering costs due to mistakes. And so really we've been able to minimize mistakes to less than probably $50,000 a pop, which is really, really good. When you're working in cutting edge tech.
Yeah, and I would think that because of the autonomous vehicle market is growing, you never make your biggest advances in the technology than you do in this very beginning phase, right? Things are moving really, really fast, and I'd have to think that in some ways you've been able to benefit by that, by these these Tesla or whatever, these taxis, going out probably by the thousands, or and what people are learning there. So what of that, what I would consider of the more what's so-called maybe some of the tried and true navigation technologies and whatnot so far, what has where have you had troubles bringing that into our industry? Where is it tough to enter the ag space compared to the driving through the city of fill in the blank?
Yeah. So speaking of that, that's one of kind of the earliest mistakes. Is there's a lot of software and frameworks and dedicated hardware out there for on-road autonomy. NVIDIA is not only kind of the biggest hardware manufacturer when it comes to machine learning, computer vision, and self-driving vehicles, but also, one of the most important companies out there as far as software development and frameworks and building standards and kind of building the tools that teams need to bring autonomy to the real world. And so early on, we tried to kind of integrate with their system, thinking if it works for on-road, maybe we can kind of push this in a different direction and use a lot of this existing technology and just push it into the feedlot and take this broader tech stack and narrowly focus it on feed yards. And that did not work. We found out very quickly that trying to directly adapt on-road and on-highway autonomy for an off-highway feedlot scenario was not the way to go. And so we took a step back and realized we're going to have to build most of this ourselves. Luckily, it doesn't need to be built to the same scale as NVIDIA does. But yeah, a lot of the all-in-one solutions or the big frameworks don't translate directly, but the sensors, the compute, and individual algorithms and localization and perception stacks, you can bring those directly into the feedlot without a ton of issue. And so, for example, all of the sensors that are on our vehicle were developed for, at least on-highway, off-highway mixed use. I believe we only have one type of sensor that was directly developed for off-highway use. But we have to go in and verify, does this continue to work in very dusty conditions? Does this continue to work in, very icy, sleet, snow, all of this stuff? But we've been able to still bring it in. And so we've benefited a lot from the technological advancement and also kind of the economy of scale that comes with more players in the urban and highway autonomy, where sensor costs have come down a lot. When we started, a LiDAR sensor cost us $35,000 for a single sensor, and we're getting down to where production costs are, between $5,000 and $10,000 a sensor. And so it's still, if you were going to build a consumer product, it's still kind of mostly unattainable unless you're at massive automaker scale. But for niche applications like the feedlot, the cost is starting to make a lot more sense. And especially over the past 2 years, there's become a lot more clarity and standards for off-highway autonomy, specifically with like agricultural machinery. And so that has helped us a lot. When we first started, there wasn't clarity for on-highway autonomy, let alone off-highway autonomy. And so that has gotten a lot better over the last couple of years as well.
Jacob, I know earlier in the conversation you shared about how ALA has evolved from starting with that driver information system up to a more fully autonomous system. Just now talked about how you've been able to integrate some of the tech that's available out there off the shelf. Now I was wondering if we could maybe take a little deeper dive, however, without completely giving up the secret family recipe of ALA engineering here, just as to bringing everything that we've talked about together. How is your feed truck different than a traditional feed truck, and just what are the basics of how it works? And I'm just thinking of this from the perspective of, I know there are cattle feeders here in Nebraska and beyond who listen to Sustaining the Herd, and I'm sure they would love to just hear some of the kind of basic overview of how's this system different, and how's it work, and why should I be excited about it?
And I'm just going to piggyback on Brock's question and say, because maybe it could be all part of the same answer. Is this something where, do you have to drive that route first, or do you program the route? So don't answer that now, but go ahead and go with what Brock asked.
Give us the rundown. Without giving up the whole secret family recipe.
Yeah, so we're trying really hard to make a entire solution or a product, and so there's two really big parts of that. Number one is the truck itself. And so traditional vocational truck manufacturers, the feedlot industry is too small, and really heavy duty vocational trucks and the manufacturing scales that they're being built at has been on downhill for quite a while. And so there's a lot of issues why standard feed trucks today are not well enough suited for their environment, especially for long-term sustained use. And so we've actually developed and are building the chassis itself from the axles up. And so using the heaviest duty axles and frames and the diesel engine and going to a fully hydrostatic powertrain has all really allowed us to build a truck that's not suitable for on-highway use whatsoever, but it is purpose-built for the feedlot. A max speed physically limited at 15 miles an hour, but a much smaller engine than a traditional feed truck with much more power than a traditional feed truck, and really, really accurate at those low speeds that are required for feeding. And another big part is there's zero shock loads on the system. And so we essentially just have a pump engine, and all it does is it spins a hydrostat all day long. The engine can stay right in its power band, peak fuel efficiency, clean fuel burns, so that we also see kind of decreased emissions, especially like those long hydrocarbon chains. And so just like a cleaner usage of fuel, less usage of fuel. And because the engine's just running in its power band all day long, we're hoping to see way better long-term survivability of these engines, a lot, decreased costs for maintenance, and all of these different things. And so the truck itself has been built as well as we can for the feedlot industry directly. Then on top of that, we bring in the autonomy. And so we're already trying to save on costs for the truck and make the truck more reliable. But the next step of that is you have people in the yard who have better things to be doing than feeding cattle. There's ongoing labor shortages, and the labor you can find doesn't stick around long, and therefore doesn't become that skilled driver that you really need to stick around long term. And then the people that do stick around, that you have to feed every day. Doesn't matter if it's a holiday, doesn't matter if it's kind of the nastiest day out there. You have to have these animals fed every day. And so just even things like scheduling and availability of your staff becomes an issue. The autonomous driver can drive these trucks much more carefully than a human driver does. We can kind of baby the equipment so that we're not taking sharp, fast corners. We're not, ripping down to get to the other end of the yard as fast as possible and causing safety incidents. And so the driver itself is just nicer on the equipment, nicer on the yard and everything. And then we bring in kind of the accuracy, the consistency, and all of this feeding. So what it really comes down to is we bring in a truck to your operation, and we give you a tablet that you can control this truck with. And so we can integrate one truck into an operation with other human drivers. Long term, we can start to phase human-driven trucks out, as those trucks would get phased out anyways. So instead of buying a brand new human-driven truck, swap in one of ours. We don't necessarily want to come in and swap out 6 trucks in a single day. We want to ease operations into autonomy, and so we've done a lot of work in making sure that autonomous and human hybrid operation within a feedlot is safe and reliable and still as time and fuel efficient as possible. But eventually, as you bring in more autonomous trucks to your fleet, you can have 2 people on site maintaining the entire fleet of trucks. What we generally look at for a mid-sized to large operation would be a mill operator and a driver supervisor running the entire fleet of feed trucks, running as long of a duty cycle as you want. If you want to maintain 6 hours a day of feeding, awesome. If you want to try to step into 12, 18, 20 hours of feeding a day, our system's here to support you in that. And so 2 people can run this entire fleet, and we're just transporting feed from the mill to the bunk. Keep your existing ration management system. Keep your existing software and infrastructure and sensors and data everywhere else as is. You don't need to come in and make these massive changes. All we're doing is we're coming in and we're automating that feed delivery from the mill to the bunk.
That's interesting. And follow up to that, Jacob, as you talk about increased efficiency, the potential to run longer duty cycles. I realize duty cycle depends on a feedlot owner or manager's preference for feeding hours, but nonetheless, you mentioned, maybe say it's time to buy a new feed truck and you have a few of them. Maybe you get one of these instead of a traditional human-driven feed truck. My question is it a 1-to-1 ratio? Does one traditional feed truck equal one ALA feed truck, or can this do the work of maybe 1.5 or 2 feed trucks just because of that increased efficiency?
Yeah, so I kind of want to take that in 2 directions. If you take an owner operator who's been feeding since they were 11 years old and put them head to head against an autonomous truck, they're going to drive faster. They're probably going to get the feeding done sooner, And so it's not necessarily that we're going to time wise or pounds per hour, let's say. We're not going to beat an owner operator or someone who's been driving truck for 10 years. We still take things cautiously and safely. We have to optimize between time efficiency, fuel efficiency, and safety and reliability. Versus a really skilled human driver can kind of toe the line a little bit and be incredibly fast and incredibly time efficient. But if you take the average or even above average driver, we're already seeing both time and accurate time efficiency and accuracy that is far surpassing what they can do as a human driver. And then, yes, you take into the account that you can run longer duty cycles, where we can see feasibly where instead of running 4 or 5 trucks on an operation, you're running 2 or 3. And you're just running them for longer hours. These trucks don't need a lunch break. They can just continue operating. But that also brings in another kind of question is a lot of yards that we talk to still want big, just massive delivery boxes, tandem axle trucks that we've all moved to because of labor issues. For the same reason a combine has gotten so much bigger, feed trucks have gotten so much bigger over the past, decade or 2 as well. We really want to push for smaller vehicles that operate more efficiently and for longer periods of time. It keeps maintenance costs down on the trucks themselves. It keeps yard maintenance down. We're just not being as hard on infrastructure with a single axle truck carrying 18,000 pounds of feed as you are with, a tandem axle truck that might be hauling 40,000 pounds of feed at a time. And so even if our smaller unit has to make that run twice, you didn't have to take a human's time to directly run that same run twice. And so we want to push for smaller units that run more often, but we recognize that certain operations still want to run big trucks. And so we've architected everything so we can still run those big trucks. And as far as time efficiency, an autonomous massive delivery box is going to absolutely crush pretty much any time efficiency that you've seen out there. You just kind of lose out on the benefits of having more smaller trucks. That also gets into if you have one big truck go down versus one small truck, you lose a bigger percentage of your total available capacity. And so there's trade-offs kind of wherever you go, but yeah, massively increased efficiencies against all but the best and most skilled human drivers.
Yeah, incredible. So Jacob, before we let you go, are you able to say what you see out on the horizon? I know you probably think you've got this far from figured out and you got a lot of work to do, and that's okay, but what else is on the horizon for ALA?
Yeah, so we still have a lot of work to get done to get autonomy into the feed yard. We've actually for a couple of months now had our feature complete truck ready to go, meaning we've hit all of the major features that we think we need to be able to deploy in a yard. And so this year and most of next year is focused on safety certifications and really in-depth long-term testing across all sorts of different operations with as many different users as we can find, so that we can find a lot of even just usability issues. We need to find if something that we require a operator to do is just wasting their time, or causes other issues in their duties. But a big part of that is just getting the system as dependent and reliable and commercializable as it needs to be for our scheduled launch in 2026.
Yeah.
And so getting to that finish line for commercialization is going to be a lot of work. We're very lucky to say we have the team to be able to do it. And so late 2026, we really are hoping to start commercializing this, start producing these trucks as fast as we can and getting them out into as many yards as we can. We are targeting, individual trucks to operations, so that as we scale up our manufacturing capacity, we can still get into as many operations as possible. Even if we can't bring 5 trucks to a single operation at a time at first, we can at least get you 1 truck, and get you used to autonomy and allow you to directly compare performance, cost, ROI, and everything between the human drivers on your lot and the autonomous truck on your lot. Beyond that, 2027, we start getting into a lot of the additional features that we aren't launching with. We're essentially driving a supercomputer around a feedlot covered in all of these crazy sensors that we need to be able to operate safely and reliably through all these weather conditions. But as of right now, we're just throwing that data away after we navigate. We have long-term plans to bring in the thermal imagery for, thermal anomaly detection in animals, hotspot detection, bringing in LiDAR to do bloat detection and animal gait tracking, and bringing in the RGB cameras for animal facial recognition or RFID tag recognition, and being able to actually start to tell, is this individual animal overeating, undereating? Do they have a early indicator for a health issue? There's all these other things that we can do with the tech after we're to market and after we're deploying these in mass.
Yeah.
Beyond that, there's other spots in ag that autonomy can come in. We've been approached by so many different companies doing so many cool things in ag. A lot of original equipment manufacturers who are looking to bring in driver assistance and autonomy, and just trying to find that partner is really hard. We don't have the time right now. We don't have, I can't spare engineers to go and work on these other projects. We got to get this product to market. But long term, there's so many other things that we can pursue and so many other people we can work with in different sections of the industry that we can, bring some of this tech to. And it's really exciting.
Yep. Well, I got to tell you, we really appreciate you joining us today, because I'm not sure if you've ever thought about it, probably have, but what you're doing, it is the picture postcard of sustainability in our world when you look at it, because you're feeding more accurately. It's better for the cattle, lower emissions, fuel efficiency, it's the just doing more with less. And then ultimately, labor's a big deal. It's a big part of that business sustainability piece, and so you're really hitting them all. You're really hitting them all out of the park. And so we wish you all the best as you continue down this road. And we're going to continue to watch what you're doing, and we'll be cheering for you at your launch.
We certainly will. Jacob, I have 2 really quick questions before I move to wrap us up here. Just a couple fun ones, maybe. First of all, I know the answer to this because we've been talking for a couple of years, but our listeners don't. I don't think Andrew does either. What does ALA stand for in ALA engineering?
Yeah, agriculture leveraging automation.
Now that's clever. I wanted people to hear that, because I think it's a really cool meaning behind the name.
Yeah.
My second question is, as I said earlier, I know we have some cattle feeders and other livestock producers who are faithful listeners here on Sustaining the Herd. If they were intrigued by anything they heard today, what is the best way for them to get a hold of you to talk about maybe getting one of your units on their operation in the future?
Yeah, so our website is ala.engineering, and our email address is hello@ala.engineering.
There you go. You heard it here, folks. Get a hold of Jacob if you'd like one of his feed trucks on your operation. So with all of that being said, thanks again, Jacob, for being our guest today. We've really enjoyed having you. And to all of our listeners here today, whether faithful returning listeners or those checking Sustaining the Herd out for the first time, thank you for choosing to spend some time with us. And we look forward to being back with you again in a couple of weeks with another fun episode. Until then, thanks for joining the herd today.